Hey, today we're going to implement a camera system and we'll also add textures. Alright, so we're going to start off by just deleting the player sprite. Since we're not going to need it, we're going to create a new folder and let's call it sprites. Now let's open up that folder, and I've linked an assets folder down below in the description. Make sure that you select everything including the meta files and you just drag it into Unity. Besides that, we're also going to create a little folder for our scripts, so we'll just say create folder and we'll say scripts, and we'll put in all of our scripts like generic, movement and so on, and just drag it in there. Now we're going to go over to the main camera and we're going to add a little script and we'll call it FollowPlayer. And I'm also going to be dragging this into the scripts folder. So first we're just going to delete everything over here and also these two over here, like so. And now we'll put in the variables first. So we'll say public vector2 camera offset and public float interpolation time, and we'll set this to 0.1. Now we'll say public transform player, then we'll say public transform ground camera, then we'll say public transform top ground, then we'll say public transform background, and then we'll say public movement player script. Now two more private variables, we'll say vector3 NewVector and bool first frame, which we'll set to true. Now we're also going to be adding the functions, so we'll start off by saying void fixed update, and we'll also add void FreeCam and also void StaticCam. So how do we actually determine when to use a FreeCam and when to use a StaticCam? Well, it actually depends per game mode. The cube game mode is a FreeCam, while something like the ball game mode is a StaticCam. So that means we'll have to add a value in our movement that keeps track of that. We'll measure this with the screen height of the game mode, and I'll explain what that means exactly in just a minute. But first, let's just implement that array of values. And it's going to be an integer. So we'll say public because we want to communicate with our FollowPlayer script. Then we'll say int, and we want this to be an array, of course. And let's call it screen height values. And it's going to be equal to those numbers. Just quickly pasted it in because I don't feel like typing it. But I'm just going to quickly show you how we can determine whether it's a static or a FreeCam based on these numbers here. So as you may know, the cube and the robot are FreeCams while the rest is static. And what do you notice about these two values? They're both above 10, which is the highest screen height. So we're basically saying if the screen height is above 10, then that means that it's going to be a FreeCam. That's kind of how we measure that with this. And now we can also use these values to literally indicate how much space the player is going to have vertically. Okay, so now that that's all set up, we'll go back to our FollowPlayer script and we're going to write our first if statement. So we'll say if, and now we're going to pull out the screen height values. So we're going to say player script dot screen height values, because this is an array, we'll have to point out an element which is going to be our current game mode. So we'll say player script dot current game mode, and of course we have to invert this to an integer. So we'll say int, and now we will say if it's above 10, then what we're going to do is we're going to call FreeCam. If it's not above 10, then we're going to call StaticCam. Okay, so now that that's out of the way, let's start with giving the functions some arguments. What we'll do first is we'll say bool do instantly, and we're going to add this on both functions. We'll also say first frame is false at the end of the first update, and we'll pass on first frame, so that the first time we run this, it will immediately go to the right value, and then from then on forward, it will smoothly transition to the new values. Okay, so we're going to start off by saying float yLastPortal, and we're also going to add int screen height. And you're probably familiar with screen height by now, but yLastPortal basically indicates the y coordinates of the last portal that the player has entered. Okay, so now we also have to define those values, right? Float yLastPortal, we don't have anything for that yet. For now, let's just say 0. And the screen height we do have, which is this over here. So just paste that back in, and that's all set. Now we're going to add one last function, so we'll say vector3 interpolate vec3 given our current vector and a target vector, and then lastly a speed. I'll say return, and we'll start off with the current vector. We're going to add a little bit to that vector. We're going to say target minus current, and we're also going to normalize that. So we'll say vector3.normalize, which, as it says, makes the vector have a magnitude of 1. Then we'll times that by time.delta time, and we'll times it by speed, and then times it by math.clamp vector3.distance between the current vector and the target vector. And we'll make the minimum value 0 and the max 1. Essentially, once the current vector gets closer to the target vector, this little part here makes the interpolation slow down until it reached the target vector. Alright, so now we're going to implement the FreeCam function. We'll start off by defining the ground camera position. So we'll say ground camera dot position is equal to interpolate vec3. For the current vector, we'll say NewVector3, where the x is going to be 0, y is going to be ground camera, the position.y. And then for the second vector, the target vector, we're going to say vector3.up times the camera offset. And then we'll set the speed to 20. We'll add vector3.right times math.floor. We'll say player.transform.position.x divided by 5, and outside of that we'll times it by 5. After that, we'll say if vector2.distance between top ground.local position and vector3.up times 20 is below 0.3, then we'll say top ground.gameObject.setActive to false. Then we'll say if top ground, then top ground.local position is equal to interpolate vec3, where the current vector is going to be top ground.local position and the target is going to be vector3.up times 20, and we'll set the speed to 100. Then we'll say if not do instantly, so when it's not the first frame, then we'll say NewVector plus equal vector3.up times math.lerp. Then we'll take a as player.transform.position.y plus 1.7 minus NewVector.y, and we'll put b to negative 0.6 minus NewVector.y. Then we'll set the t to player.position.y is below or equal to 4.2. Then we'll set it to 1 if it's true and 0 if it's false. And then we'll times all this by time.delta time, and we'll divide it by interpolation time. And if it is the first frame, then we'll say NewVector plus equal vector3.up times the player.transform.position.y plus 1.7, and that's the FreeCam. Now we're also going to be implementing the StaticCam function. We'll start off by saying top ground.gameObject.setActive to true. Then we'll say ground camera dot position is equal to interpolate vec3, where the current vector is NewVector3 0 ground camera dot position dot y. The target vector is vector3 dot up times math dot clamp where the value is going to be y position last portal minus the screen height times 0.5, where the minimum value is camera offset dot y. The maximum value is just the maximum value of the float. Then we'll set the speed of that to 20. Then we're just going to add vector free dot right times math dot floor. Here we'll say player dot transform dot position divided by 5, and we'll times this by 5, and that's that. Player position dot x, of course. Well, that is the longest of them all. After this, everything is fairly short. Now we'll say top ground dot local position is equal to interpolate vec3, where the current vector is going to be top ground dot local position, and the target vector is going to be vector3 dot up times 4.5 plus screen height, and the speed is going to be 30. So say if not do instantly, right? If it's not the first frame, then we'll say NewVector plus equal vector3 dot up times 5 plus math dot clamp, where the value is going to be y position last portal minus screen height times 0.5. The minimum value is camera offset dot y, and the maximum value is going to be something big like 2048. Then we'll minus this by NewVector dot y. We'll minus this by 11 minus the screen height times 0.5. And we'll times all of this by the delta time, so time the delta time, and divide that by the interpolation time. Then we'll say else NewVector plus equals vector3 dot up times, and we'll use a similar structure here. So actually I'll start off by just copying this over here. Now we'll just skip all this and we'll just say minus 11 blah 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 times 0.5. like so. Now we're done with the StaticCam and the FreeCam, but now we still have to do something with these new vectors. Those new vectors are essentially an indication of how the position of the camera is going to change that frame. So basically we'll start off by saying NewVector is NewVector3. We'll say the player.position.x plus the camera offset.x, which will just be the x coordinate of the camera. Then we'll say NewVector.y and just minus 10. We say NewVector.y because these two functions are the ones that are responsible for changing that value. So in here we'll say transform.position, which is the position of the camera, right, is equal to NewVector. Now we'll do one last thing, and that is define the yLastPortal, which we just left at 0. So we'll start off by going into our movement script, and here we'll add a new variable. We'll say public float, and we'll call it yLastPortal. What we can do real quick is we can just say system.nonSerialized, so that way we don't see it in the inspector, and we can also do that for our screen height values. And I'll put these together nicely like so. And now we'll also set yLastPortal to -2.3. We'll scroll down all the way to our change through portal here, and we'll add a new argument. We'll say float yPortal, and in our game mode we'll say yLastPortal is equal to yPortal. Now inside of our portal script we still have to define the yPortal. That's very easy. Here we'll just say transform.position.y. Now back in our FollowPlayer script we'll just say player script.yLastPortal, and that's that. Here we'll do one more thing, that is change the position of the background. So we'll say background.localPosition is equal to NewVector3. Here we'll say minus player.position.x times 0.5 plus math.floor. Here we'll say player.transform.position divided by 96, transform.position.x. Then we'll times that by 48, and y is going to be 2.2 and z is going to be 10. And that is the entire camera script. That was it for today. I hope you enjoyed the video. In the next episode we will do the necessary scene setup alongside perhaps orbs or pads or whatever. See ya.